Hello and welcome to our data planning and data collection notebook at the basic level. So we have two versions of this notebook, one for a basic level and one for an advanced level. And this is the one for basic level. So in this notebook, I will show you how you can select, download, prepare and process data that you can then use to train NMT models. So I will show you everything starting from how you can find data, how you can download this data directly into this notebook, and then also how you can process this data. Data processing is a very important aspect for NMT training because data can often be noisy in the sense that it can contain empty lines or it can contain sentences that might be too long or too short, or they could contain, for example, HTML or other aspects that in the sense of NMT would be called noise because it is not something that we need to train the NMT models with. So in order to process this data accordingly, you can just follow the steps in this notebook, and at the end of it, you will have your processed data that you can then use to train your own NMT model if you wish. So in this notebook, we have prepared some background information on what you will be doing in this notebook, why it is necessary, some relevant links that you can look up if you want some more information on this topic. So I won't go into detail here because you can read this if you have a look at this notebook, but I would specifically show you the steps that we'll take and kind of what is important to focus on so that you can do it yourself as well. So the most important thing is that in this notebook, we have these aspects where, first of all, we have some text written that you can always read because it will explain important things, and also what you should or shouldn't do regarding the code blocks. And then you have these code blocks in here that you can run yourself without changing anything in the actual blocks. So I will show that as we go along. So the most important thing here is that is to start off actually getting your data. And one really amazing place to do so is Opus. So I will show you right here. I haven't prepared any of the links. I haven't opened anything before, so just that I can show you right here. On Opus, there are a lot of parallel data sets, and parallel data sets means that it is bilingual. So you have a data set with two languages. And for our scenario, we chose the language pair English-German. So to do so, you can select your languages on this website, which you don't have to do for this notebook, but just to show you where we're getting this data from. You can, for example, select English here as the source. Then you have to wait a second because the page reloads. And then for the source, you have English, and then you can select, for example, German as well, and then automatically all the data sets here for the parallel pair of English and German will be shown. So these are different data sets, and then it shows you here also how many sentences are contained in these data sets, and this means per pair. So as you can see, this is a massive data set, the Paracrawl data set, with more than 200 million sentences, and the lower you go, the smaller the data sets get. And for this one, so you can also see the languages here. So you can also see the language pair here again, just to be sure. The data set that we're working with for this notebook is the TED 2020 data set. So you would have to look on the left-hand side where you can see, okay, TED 2020. And you can always look on the sample button, you can always click on here, and it shows you how the data set looks like. So kind of how the sentences are structured, what the domain is, if you're not sure how the sentences are formulated. So you can just have a quick look at the sample button. And then if we go back, we can choose the data format that we need. And this is achieved by clicking on Moses. If you right-click on this Moses label, you can download, you can copy the link, and as you can see, this link is also shown in the bottom left corner because this is the link that we're working with. So in case you want to find your own data set or your own language pair, this is how you can download the data. By clicking on Moses directly, it will straight away download it, but by right-clicking on it, we'll copy the link, as you can see down here, and this is the one that we'll be using. So this is just to show you where we're getting the data set from. And then if we go back to our notebook, you can see this right here is the link that we've just copied, for example. Okay, so we can see here it's from Opus, the TED 2020 Moses version for German and English. And then the first thing you can do is just straight away run the cell. So you click the button. By clicking on this cell block, it will automatically download the data set and then also unzip it, because we tell it to unzip the file. And then as an output, you will see in a moment, we will get the two separate files, one for German, that's the one ending in DE, and one for English, that's the one ending in EN. Then we'll also have the XML file that we won't be working with here. So the two important ones that we need here are these two, the German and the English side. So once you have that, we can actually work with the data that we've just downloaded, and it's right in this notebook now. And then first of all, we have to install some necessary requirements for Python. We won't go into too much detail here, but you can just run the cells here, and you can always see it always takes a few seconds, usually not much longer, to run these cells. And you can always see sort of the outputs of what the cell, like what is happening, what it is doing, and you know what it is downloading. And then you can always see, for example, successfully installed. You can either leave this, or if it bothers you, if you don't, because we don't need this, you can also click on this X here, and then it just takes that away so you don't visually see it. But you can see on the left there's a little green tick, and that shows you that the cell has been successfully run. So what we then do is we clone our GitHub repository. So by clicking on this link, you can see our GitHub repository. And on our GitHub repository, we have a folder for data preparation. And this one has pre-written code already in it. So you don't need to focus on this, but just for you to know that this is code that we are using in our notebook. So in order to get this code, we have to clone, so kind of copy our GitHub repository into this notebook. So you can just click the cell, you don't have to change anything, and it'll say done at the end as well. And then we can officially use the code straight away from our GitHub repository without writing the code ourselves. So the next step is that we define the files that we'll be working with for the code steps later on. So we'll use the source file, the TED 2020 file for English, and then as the target file, we have the TED 2020 German file. And we define the source language to be English and this target language to be German. So you can just run the cell. If you, of course, use a different data set, you would have to change these names in these strings here, and potentially also the language codes. If you're working with French or Spanish or the other way around, then you would need to change these codes here. But otherwise, if you are just running the notebook as it is, you can always just click every cell without changing any of the information in it. So now that we have defined our source and target files and our languages, we can move to the next step where we actually clean the data set. So in this section, we will delete empty rows. So if there's an empty row in the data set, we will delete duplicates, source copied rows, or sentences that are too long. We will remove HTML code, and we will also shuffle rows in the end. So the next thing you can do is you can just click the cell, because here we're referring to our DataLitMT GitHub, which contains our code. And we defined here the source and the target files, and then also the source language and the target language as we defined up here. So you don't need to change anything, just for you to know kind of what we've written in the cell. You can just run this code block again, and this will automatically perform these steps for you. So you can already see here the rows with empty cells deleted, and then these number of rows are the ones that are kind of left over. So we start in the beginning with 300,000 sentences for English and 300,000 sentences for German. So 300,000 parallel sentences. And then when the empty cells are deleted, when duplicates are deleted, and so on, you can see at the end the number of rows we actually have left are 268,000, more or less. So in this step, it shows you also what is being done. And then at the end, you can see, okay, we now have a new saved file for source and for target. And now we have this extra information here called filtered. So we know that these are now our filtered. This is now a filtered data set, both for English and for German. And you can see it here as well. These are the outputs that we should receive. And the good part is that you can always check that this has been done correctly. You can check that, okay, that we're working with the correct files and that we're working with the correct languages. It's always good practice to check a few lines. So if you run this cell, you can just see, okay, prints the first 2 lines of the source of the English data set, and then the first 2 lines of the German data set. And if you speak these languages, you can see, okay, this is actually the parallel. They are parallel. This is the translation of this. And then you can also check the last 2 lines of the English and of the German data set. And once again, check that this is actually in the right order. So it's always good to check data sets. All right, so now we actually already have our filtered data sets. One next step for preparing data sets to then use for NMT training is that we need to tokenize this data, which is also called subwording. And in order to do that, we use a subword tokenization model called sentence piece. So subwording means that it splits the words into smaller units, so subwords. And then these words can be used for better training for NMT systems. Because as you can see here, for example, if we have 4 words called low, lowest, high, and highest, they can be represented by the 3 subwords low, high, and est. And that reduces the required vocabulary size of the NMT model by 1. So these subwords are the ones that NMT models use to train. And we will show you how they look in just a moment. So in order to do that, we first of all need to train a sentence piece model. And this is all also done automatically. You just need to run the cells here. But we need to train one model for the source data, so one for English and one for the target data, because these languages, the sentences will be subworded a bit differently because the languages are, of course, very different. So to do that, to train such a sentence piece model, all you have to do is run the cell. And this will take just a moment, and you don't need to worry about any of this that is being printed here. But you can just see that it is loading. You can just see that it's loading. It will take a few moments. And then in the end, you will see that we get a source model and a target model. And this is the one that we can then use for the next step. Okay, I have sped that up for you, but you can see down here, it took 1 minute and 38 seconds to load. So it feels quite long, but it's only around 1.5 minutes. But in the end, you can see it says done training a sentence piece model for the target. So that is down here, and in the middle, because it does it separately, if you scroll up, you can see here, done training a sentence piece model for the source. So first it trains a sentence piece model for the source, then it changes to the target, and then both sentence piece models are trained. So one for the English data and one for the German one. And these are the outputs that we get in the end. So for the source model and the target model, we can now use to actually subword our data. So we can do so by clicking here. This takes a moment, and you can see we have the source model, it uses the target model. We have the English source data set and the German target data set. that these models now are applied on to subword them. And you can see that the output files, the names of the files now keep extending, because first we added the filtered and now we added subword. And of course the name is getting quite long, but it contains all the necessary information. So in this respect, it's very helpful, as long as we're working with the data sets, to always have a very clear name of what we're using and what we're working with. So these are now our two output files, the source, English source file, subworded, and the German target file, subworded. So now, just as we've done before, we can check our data set again, our two files. So we can print this, and now we can see that we have subworded the data. So this is how subworded data looks like. It has the underscore before it. And this all looks correct. So you can see every word is subworded differently, and it doesn't matter at the moment here how exactly it looks like, but you can see, okay, if you have your underscores, it's correct, and the files have been subworded, they have been tokenized, and this is the information that is then actually used to train the NMT engines later on. So it now looks correct, because this is how the computer reads the information. The computer reads it differently than we would read a sentence, naturally. So now we have the data set the way it should be. It's filtered, so it's cleaned, and it's tokenized. Okay, those are two very important factors. So now that we have subworded our data sets, the next step is to split these data sets. And splitting is very important, because for now what we have is we have one big data set for the source file for English and one big data set for the target file for German. But we actually need to split these files into sub-files, as for any machine learning system, because there is a data set called training data set that the NMT model actually trains on. So this is the information that the model uses to train. Then there's a development data set that the system uses to validate what it has learned. And then there's a test data set where in the end you can test your model, how well it performs. And it is always important to split the data set into these three sub-data sets. The training data set is the one that's the biggest of these. So the training data set makes up around 70 or 80% of the original data set. And the development and test data set need to be of the exact same size, and they always make up around 10 to 15% of the original data set. So the original data set that we work with here, the TED 2020, has 300,000 sentences, parallel sentences. So if we split this information up, we can say, okay, the test and the development data sets will both have an equal number of around 35,000 sentences. So that makes up round about 10%. And then that leaves this number, so around 216,000 sentences for the training data set. So this is really important, because the test data set and the development data set really need to be of the same size, and the training data set needs to be by far the largest. But we need these three sub-data sets to train the NMT model. And you can see down here as well that we define the test and the development data set to be of 35,000 segments or sentences. And if you run the cell, it will take the original input data and now automatically split this data for you. So as the output files now, we have, and once again, the name increases, but it has all the information that we need. So we're working with a TED 2022 English filtered file that has been subworded, and this is the training data set. So the ending now is .train. Then we have the same for German, where it says DE, and we have train in the end. And we have the same for the development, that is shortened as dev, and the test. Okay, so now we have these 6 data sets these 6 sub-data sets, and these are the ones that we would then actually need to train an NMT engine with. So we use the train data sets to actually train the engine, the development data sets to validate, which is also used during the training process. And then at the end, with our final NMT model, we can translate these test data sets. So it also says it at the bottom here that these are your output files. And once again, now we won't check the actual lines, but we can check the length of the data set to make sure that it's done correctly. And you can see here that the lines are of equal length because they need to be of equal length for the training. So the English development test set is 35,000 and the same as the German development. And the English and German test set are both 35,000. We can see here that the train also for the German and for the English are of same length. Okay, so the word count is here, the line count is here, and this is the name of the file. Because they need to be parallel, they need to have the same exact length. So now, the most important step at the end of this notebook is to actually save these data sets, because what we've done so far is we've worked in this notebook, and these files are part of this notebook, but we haven't actually saved them yet. So one thing that you can do is you can save them locally to your desktop and save them wherever you'd like. And to do so, you can go on the left here to this folder icon. And when you open it, you can see this is all the data that we've produced as part of this notebook. So for example, here we can see this is the first file that we've worked with, then it's the filtered file, then it's the subworded file, and then here, for example, we can see it's the development file. Here we have the test file and the train file. So these are the 3 files we would need for German, and then down here for English. And to download them locally, you can click on these 3 dots on the right side and click on, well, in English it will say download. And these are the files that we would need to download. So the development, test, and train dataset, and the same for English, the development, test, and train dataset. Of course, you can also download the entire subworded or the filtered dataset. Also very important is that we download the sentence piece models that we've trained. So we need the source model and the target model, because we need to de-subword the information later on. So if we have the NMT model and we then translate the test data set, the output that we get will also be subworded, because so far all the data sets have been subworded, and the translation output that we get will also be subworded. But naturally, we want it in natural language, so we want them de-subworded again. And to do so, we need these models again. So this is a step that is shown in the NMT training notebook. And then at the end, when you have your final translation, you can de-subword that translation. And this step, is shown in this NMT training notebook. So this is one option that you can locally save your data sets. The other option is to connect to your Google Drive, and we would recommend this step because if you work with this data, you continue using this data, especially using Collab notebooks, for example, you can always easily link them to Google Drive and reload them into your notebook, and they are well saved in your Google Drive. And also for our NMT training notebook, we refer to the Google Drive folder where the data sets are saved, and then you can directly load them into your notebook and use them for NMT training. So to connect your notebook to Google Drive, you simply have to run the cell, and then it will load, and then it will ask you if it's okay to access your Google Drive, and you just have to say okay. And then it will ask you to choose your account, your Google account. You can click on that account, and then at the bottom here you have to say allow to connect to your specific Google Drive, and then it will just load for a moment, and this way it will connect to your drive. And if it's successful, it says mounted at, and then it's connected. Okay, so what we can either do is you can just run the cell and it will copy the source model, the target model, and the 3 sub-data sets per language into your Google Drive. And my drive means that it is your main folder. So the main location that you're working in would be this my drive. But so you can either do this, you can run this and it will copy it into your original main my drive folder. And then you can check also here everything that is in your my drive, or you can go to your Google Drive and check there that the files are actually saved. It might take a minute, so don't worry. But what we could also do, preferably, also just to have some structure, is that you create a separate folder in your Google Drive. So for example, we'll call it MT data preparation. And important here is to always use an underscore or a score or something to connect the words. So we don't want an empty space. So here, for example, we'll use the underscore MT data preparation. This is now a new folder, an empty folder that we've created. And you can see there's nothing in here yet. But if it's spelled the same, then you can see this is the folder location now in your drive. And now you can copy this data into that specific folder straight away. So once again, the model, the sentence piece models for the source and the target, and the sub-data sets for the source and the target. So now you can run this cell. And if it doesn't work, then maybe you've misspelled the name of the folder or something. So don't worry, just check again or just copy paste the name. You can also rename this folder however you would like to, but then make sure that you rename it everywhere and that it's always the exact same and that you don't change anything else. But if you have named your folder empty data preparation, you can run the cell, and as you can see here on the left hand side, it's a green tick, so it should have worked. And we can actually look at our folder and we can see, okay, we have saved all of these files into my folder. It's now called empty data preparation. But just to make sure, I can go into my folder and I can look right here that it's actually saved all this data. And as you can see, it takes a moment. So I can also just reload the page here. And then I can see I have all my files saved in this folder. I have the source model for the sentence piece, target model for the sentence piece, and the 6 sub-data sets all saved in my folder of empty data preparation, as we have already checked here as well. So now you have cleaned your data set, you have filtered it, cleaned it, you have tokenized it, so you have subworded it, and then you have split your data set into sub-data sets for training, development, and testing, and you have saved all the sub-data sets and the sentence piece models either locally or to your Google Drive. And if you wanted to, you can use these data sets in the NMT training notebook to actually train your own NMT system. Or if you'd like to work with a different data set or a different language combination, you can change simply change the link here to the link of the data set that you would like to work with. And then you would need to change this information here, as I'd stated in the beginning, and then work through this notebook. But without changing anything, by just clicking on each of these code cells, you have prepared your data. So congratulations.